So they're saying that won't go away. They're saying that if f inverse of x is equal to e to the x, or if we say y equals e to the x, that's going to be true if and only if, switch your x's and y's. So I'm going to have x equals e to the y. Now we put this in log form. That's going to be log, natural log, base e of x equals y. So these two are inverses, bottom line. Now, you need to know what this is. What is ln e to the x? X. Why?
You put that step. X in front, ln e is 1.
Okay. So one option is to say e raised to what power is e to the x? X. Or you use your properties and put x in front, and what is ln e? 1. So either way you do it, this is going to be x. So if I have natural log of e to the 5th, what is that? 5. Now this is different. This is saying if you raise e to the ln x, what do you get? We don't know, do we? So let's do a question mark. Ready? This is exponential form, so I'm going to put this in logarithmic form. Log, natural log base e of our answer is equal to our exponent. Now, if I have two logarithms with the same base, what must be true about these? They must be the same, otherwise they can't be equal. So e raised to ln x is what? X. Let's take this a step further. If I have 2 raised to the log base 2 of x, as long as this base and that base match, the answer is going to be whatever that happens to be. Now, do I need to go back over these, or have we already done these? Didn't you do a whole worksheet on those? Okay, we'll do one. Let's do a more interesting one like this one. Okay, so what are we going to do first?
4.
Move the 4 by. So we got 3e to the x minus 3 is equal to 17. Now what? Divide by 3. So we're going to have e to the x minus 3 is equal to 17 thirds. Now what? Natural log both sides. Because what does this do to my exponent? It rescues it from the exponent position. So I have x minus 3, natural log e equals natural log of 17 thirds. What's ln e? So x minus 3 equals natural log of 17 thirds. What's x? So I'm going to put 3 plus natural log of 17 thirds. Or you could have added 3 at the end. Oh, how are we going to do this next one?
Oh. ln 3x divided by ln.
No. We can't do anything over subtraction. What are we going to do? What is this base? Actually, the inverse is the e function. So we e both sides. You see that? What's e raised to the ln of this? Bless you. E raised to the ln? Whatever this happens to be. You see? So e raised to this is 3x minus 5, and this is e to the 4th. Now what do? We move the 5 by. So we're going to say 3x is equal to e to the 4th plus 5, then what? Divide by 3. E to the 4th plus 5 divided by 3. Now, to be honest with you, what I tend to do is I tend to put this in exponential form. That would be e to the 4th equals 3x minus 5. I get to the same place. We just can't do that on. We have to log both sides when we're in the other situation. What do you think you should do here first? 1/2 ln x minus 5. Then what do? I think multiply both sides by, because you want to isolate that logarithm. So this is going to be ln x minus 5 equals 2. How do we undo an ln? We e both sides. So what is e raised to the ln? X minus 5 equals e squared, or x equals e squared plus 5. That's not bad, is it? My guess is you might have a few of these in this section. Okay, so let's just look at this for now. See what I want to do. Okay, so what we're going to do is we're going to look at this. I want to take the derivative of both sides. Okay? How do I do the derivative of both sides? This is going to be what? 1 over e to the x times the derivative, which we do not know, correct? Of e to the x. We don't know how to do that. What's the derivative of x? Okay, how do I solve for this? How do I solve for that? Multiply by the reciprocal, which is? Now soak this in. We're saying the derivative of e to the x is?
0.
No. Derivative of e to the x is what? E to the x. This is the only function whose y value is also its derivative. Okay, however, that's not the way that's not the rule I'm going to give you. Because what do I want to do? I can't find my shade, there we go. I want to give you a derivative rule that works for everything. So this is it. If we're going to take the derivative of some number raised to a function. Okay? So now, am I limiting this to e anymore? No. It's going to be natural log of the base times the function as it appears times the derivative of the exponent. And this is the deal. If I have something like log base 2 of x, and I need to do that derivative, we'll say x squared, okay? We don't know how to do that derivative. So we're going to say equals, we'll just go ahead and say equals y for now. That's my function. So can I put this in exponential form, 2 to the y equals x squared? Right. So now I'm going to natural log both sides. So I don't want logs, I want natural log. Y comes out front. I'm going to have y natural log of 2 equals what? Well, I'm just going to leave that as natural log x squared. So then if I solve for y, what am I going to have? 1 over ln 2 times natural log of x squared. This didn't take me anywhere. No, I'm leaving it at, hold on, I don't want to do this. I don't want to solve for y. You ready? I think? Okay, so what is this base? E. Okay, just take my word for it. I will come up with this proof. I failed miserably. Okay, so first of all, I love these derivatives. I like the logs and the natural, the e's. So what does this say? This says our derivative is going to first be natural log of the base, which is, so we could say natural log of the base times the base raised to its function f of x times the derivative of the function. So ln of the base times the function as it appears. And then what's the derivative of that exponent? Now what is ln e? 1. Now my suggestion is, because when we get into the next section, you will not have a learning curve. If you don't do this, then you're going to have a learning curve and things are going to seem more complicated than they should be. Today, it's all about e. It's all about e. So every time you do this derivative, you're going to have a what? ln e. But if you don't do that, then when f of x is 2 raised to the 3x minus 2, you are going to mess it up. Because what is this derivative? ln of the what? Base times the function as it appears. And what's the derivative of the function? 3. Now, you want to put this in parentheses because exponents come before multiply. You cannot multiply this base by anything. You see, does ln 2 disappear? It does? No. ln 1 is 0. Was this ln 2 going to disappear? No. Did the ln e disappear? Yes, it did. But it won't all the time. So my suggestion is do this all the time tonight. Then when we get to this, which is I think in 2 days, it will be a piece of cake. In the meantime, can you simplify this? ln of e to the 4x squared is what? This was that property I gave in the very beginning, right? E raised to what power is e to the 4x squared? Isn't that 4x squared? Yes, no, maybe? Yes. So what's the derivative of y? 8x. Now you could have left it in this form and that would have been really messy. It would have been. Do you want me to do it? Let me show you how messy it could have been. This would have been 1 over e to the 4x squared, right? Yep. Times the derivative of the inside, which is going to be ln e, times e to the 4x squared, times the derivative of the exponent, which is 8x. Those simplify. That becomes a 1. I've got 8x. That's working hard. That's working smart. So, let's look at this one. Is there a rule? Not at all. What about there? Isn't that multiply? And Emily had it. Are there x's on both sides? So what do we have to do? So we say first, right, times the derivative of the second, which is ln e times e to the x times 1 plus the second. What's the derivative of the first? Okay, now minus this. There is no, what am I going to say? There is no product rule here. So it's going to be ln of the base times a function as it appears times the derivative of the exponent, which is -1. So you've got x squared e to the x plus 2x e to the x plus e to the negative x. You with me? What can be factored? What can be factored? E to the negative x. Why do we choose negative x? It's the smallest. Minus a minus x, minus a minus x, right? Because when we factor, don't we subtract exponents? So this is going to be x squared e to the 2x plus 2x e to the 2x, and now that will be e to the 0, which is 1. Kind of cool, don't you think? Was that sarcasm I heard? No. Not at all. Not from you all. No, of course not. These aren't bad, are they? Do you wish we had learned these back when we did all the derivatives?
Not really. That would have been too much.
Isn't it kind of nice to revisit the derivatives to bring that back fresh in your mind right before the AP exam? Which one do you think looks ugly? The last one? You want to do a quotient rule? Let's do it. So this is going to be h prime of x. You ready? Let me get a fraction bar. We're doing the, yeah. So we're going to say denominator, which is 5 minus e to the 2x, times the derivative of the numerator, which is ln e to the 2x times what? 2, minus the numerator. What's the derivative of the denominator? 0 minus derivative times, and this is all going to be over 5 minus e to the 2x quantity squared. All right, so that's 1. So I'm going to have 2e to the 2x times 5 minus e to the 2x minus e to the 2x times, this looks like that's going to be negative 2e to the 2x. Am I right? So what do you think I should do next? Factor or distribute? What are we going to do? We could factor. Do you want factor? What can we factor? E to the 2x and, don't they both have 2's? Because that will simplify with that. So that leaves me with 5 minus e to the 2x. The e to the 2x came out. This 2 came out, leaving me with plus e to the 2x. Oh my, what happened? What cancels? Inside, right? Gone. So do you agree that's going to be 10e to the 2x over 5 minus e to the 2x? We can't separate over subtraction in the, right. Can you cancel those? No, because of the subtraction. Can we take 5 into 10? No, because of the subtraction. The bottom is still squared. There's another really good reason why we don't touch that. That's the first reason. All right. What else is here? I do not believe. Did anybody have the... Shall we integrate today? We quiz tomorrow? You want a quiz? We could have a quiz today. You want a quiz today? No. All right. A24. Let me look. We might be doing this. Take my time. I don't want to run out of time. This says tomorrow is 99 through 125. All right. So this is what we're going to do. This is tomorrow's lesson. So your job, you've got 10 minutes. You've got 11 minutes. So, no. Your job, I'm thinking 1 through 3. We'll start with 1 and 2. No. I've got time for you to do it. So you're going to raise your hand when you have an answer so I can check it. I will give you a little happy face.